anyone's first time, hello, welcome to Intro to Physics. I'm gonna be the only teacher for today. Jethin's somewhere else and Lucas is also somewhere else, but here to help me out is Ethan. So feel free to ask any questions in chat. He will be more than happy to help you. And today we're gonna be going over kinematics. So last class, again, if anyone wasn't here, we were going over the just a preview of what kinematics was. Like we talked about velocity, acceleration, time, and displacement. And now we're going to be using those four quantities to help craft and create some equations to solve some problems. So, but first, I want you guys to understand what a reference frame is, okay? So a reference frame like is motion is always like measured relative to something else, right? So if I'm running on a track, I'm running 10 miles per hour relative to the ground, right? Or relative to someone else standing, right? But if I'm in a car going 60 miles per hour and there's another car going 70 miles per hour, that car is going 10 miles per hour relative to me, right? Does that make sense? If does that make sense, right? But if I'm standing still and that car is going 70 miles per hour, now it's going 70 miles per hour. Okay. So that's basically what the reference frame is. Right now, I don't think um the reference frame will change. It'll be mostly in the view of ground or standing still. But if it does ever, we will state that in the problem, right? So another thing I want to tell you about is sorry, trying to annotate this. Um, I'll just annotate it on here. So, another thing I wanted to tell you about was delta. So if you ever see this triangle like symbol, I didn't try it so well, but if you ever see this triangle like symbol, that means it's it's a change in, right? So if I'm doing delta x, we know that x represents displacement, right? If I'm doing delta x, and let's say I'm at x equals 0, right? And then I get x equals 10, right? Let's say Bob is standing at his starting point and then moves 10 steps, so then he's 10 meters away, right? Now he has a displacement of 10. So the delta of x would be 10. This is very important because we never, this is the fastest way to signal a change in, right? If we ever want to signal a change in, we'll be saying the delta of x or the delta of y or the delta of whatever, right? So, do you guys get that part? It'll all make sense a lot better if you guys understand this basic concepts. Okay, let's move on to the four kinematic equations that we will be crafting right now. No, Bob is not X. Bob is the person going, starting at X meters, 0 meters, and then going to 10 meters. I just use a name to kind of, yeah. So these are the four kinematic equations that we will be creating and then working with later, right? So I want you guys to take your pencil and paper, and I'll give you guys 5 minutes to write these down. And then I'll explain what each one does and what like each one is and why we have each one. So go ahead, get your pencil and paper and write it down. I'll give you guys until 2:14. For the people saying they don't get it, could you guys explain what part of the um place you are not getting? Do you not understand these equations that are on the board right now? Because if you don't understand these equations on the board right now, I'll tell you that in a second. Don't worry about yes, you can take a screenshot, but if you don't get these equations, that's what I just want you guys to copy this down in your notebooks, and then we'll use a separate page and I'll tell you what each of these things are. That's I. That's an I. Okay, the I and F stand for initial and final. So take a second to. Hmm, okay, this is a lot easier. Um, the triangle is delta, which is just the change. That's what I talked about earlier. Let's do this. Let me. Okay, so delta is equal to change. Ooh, that's not a good. Sorry. You guys good to go? Yeah, I'll go over delta. I'll go over everything in this um on this page right now. So don't worry if you guys aren't getting it right now. Are you guys good? Just type in chat if you guys need more time to copy it down. Are you guys good? Good. Good. Okay. So this is gonna take a few, but I'm gonna go over everything on this page. And if you guys still have questions, feel free to ask. Okay. So we know at last class we defined x equals, sorry, wait, there we go. Okay. X equals meters, right? X equals the distance, or sorry, displacement, right? So in this click case, whenever we see X, we think of X as so in the first equation, we have X sub I and X, right? So when I say X sub I, that just means this, right? The sub means subscript. So this is technically X sub I, okay? I'll just say X initial for now, but so X initial is where the person starts, right? And when we take this X, that's the final. This is the final place they end up. So with the example I used earlier, if Bob starts at 0 meters, xi here, xi would be equal to 0, right? But if we're, so this first equation, this is used for trying to find out where Bob would end up, how many meters away, right? Do you guys kind of get that? So if x starts at 0 meters, and we even did a problem, right? So let's define v equals velocity. Yes, x initial is where Bob, or I'm gonna keep on using the Bob name because that's the simplest one I can think of. So that's where Bob will start, right? You can also think of this kind of logically. Yes, and X is where the person would end up, right? You can kind of think of this logically, right? If a car is going 30 meters per second for 3 sec, we did a problem last time, right? If a car, or let's say Bob, if Bob is going 10 meters per second for 3 seconds, if you ever see this kind of problem right here, you can assume Bob is starting at 0 meters, right? And if we want to find out where he ends up, we just do 10 times 30, right? What if Bob can fly? If Bob can fly, then he would still be flying at 10 meters per second for 3 seconds, right? Walking or flying, it would be the same speed because I defined the speed. That's a good question, though. Um, but if Bob is going 10 meters per second for 3 seconds, we know 10 meters per second, that's the velocity, right? Because it's meters per second, right? Okay. And 3 seconds, that's the time. You see how that correlates to this equation right here? So if 10 meters times 3 is equal to 30, then we already know that this is already part of the equation, right? And let's say Bob starts at 10 meters away from the starting line, right? If Bob starts at 10 meters away from the starting line and ends up, and we want to know where he ends up, right? We know that he is going 10 meters per second for 3 seconds while he starts at 10 meters, right? So if x, the initial, is equal to 10 meters, and the v is equal to 10 meters per second, and if he's doing that for 3 seconds, he goes 10 times 3, which is 30, plus when I said he started at 10 meters. Then his final distance would be 40 meters from the starting point, right? Relative to the starting point, he is 40 meters away because he already starts 10 meters away from the starting point. Does that make sense to you guys? Could you guys type something in chat? Okay, we're getting a lot of yeses. Does that clear up the first equation? And I want you guys to notice this missing part is very important here. Notice how there's no acceleration in this equation. This equation uses distance, velocity, and time, right? Only these three quantities. I want you to, this is why I chose this specific picture, because it has the units section and it has the missing section. This is a very good picture, right? Can I go on to the next equation? Are you guys good with the first one? Oh, what does VT mean? Um, VT means velocity times time. Velocity times time. So whenever you see two variables like this together, um, if you guys are new to that, that just means there's a multiplication symbol in between those two quantities. Does that So if you guys ever have private messages to me, or if you guys ever have questions that you want to send privately, I recommend sending them to Ethan because I'll be teaching in the class. So does that kind of help answer the question of what does VT mean? Okay. I'm just gonna repeat it one more time if someone is still confused. Velocity VT is just velocity times time, and you can just use a simple um thought process of if someone's going 10 meters per second for 3 seconds, then they're going 30 meters overall, which is also that, right? So a lot of the times A is acceleration. Right now, we did not work with A in the first equation. I'll get to the acceleration next. But a lot of the times, the initial x will be zero unless stated otherwise, right? So don't worry about this too much. The main thing is x is equal to how fast you travel for how long you travel. That's a good way to think about it. Okay, moving on to the next equation, right? This next equation, you're working with v sub f, which just means the final velocity of something, right? If if a car is initially going 10 meters per second and you want to find out how what the speed is at the end, you have to know its acceleration, how long it's accelerating for, and the initial velocity is going at. The same thing with um, the initial distance. The initial velocity is usually zero, but more frequently than the distance one, the initial velocity could end up starting at like 10 meters per second or 30 meters per second. It depends. This is why you have to read problems very carefully. Let's say now Bob is going 10 meters per second in the beginning. You see how I put in the beginning there? That signals to you that initially he is going 10 meters per second, right? What does F mean? Oh, the F means final. So velocity final is the ending velocity that we want to know how fast it's going, right? If Bob is going 10 meters per second initially, right? Initially going 10 meters per second, and then he is accelerating at 3 meters per second squared, and we always work with constant acceleration, right? Someone's not going to be accelerating for 3 meters per second, then five, then four, then three. We're always going to be talking about constant acceleration, right? So if Bob is going 10 meters per second initially, but then starts accelerating by 3 meters per second squared for 3 seconds, this is how we can calculate, and it's asking for its final velocity. What is final velocity is final. I'm just going to say what is final v. This is how we can use this equation to help, right? So we can set our first variable to, we know the initial velocity is equal to 10, and we know that the acceleration is 3. Oh, always add units, by the way. I shouldn't not forget it. Meters per second squared, and then t is equal to 3 seconds, right? We know all three variables to solve for the final velocity, right? Which makes sense again, right? If you think about this logically, if a car is constantly accelerating for 3 meters per second squared for 3 seconds, if you just do 3 times 3, you know that the car is going 9 meters per second at the third second, right? That makes sense, right? With that, that is basically this. And then when you add that to your initial velocity, that's when you get your final velocity, right? And here X is clearly missing, right? We do not use X in this equation. We use the velocity, acceleration, and time, right? Those are the three things that are needed. Do you guys do you guys have any questions on the second one? Is this making sense? Is this making sense? Yes. 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 Okay. Good, 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 good. And don't worry about how we got these equations. That's what we're going to be doing next. I just want you to get an understanding of what these equations are, right? Then, okay, the last two are the trickiest, right? You guys are going to really have to focus in, okay? These two are more these two you're gonna have to create, right? You can't think about these more logically as the other two, where you could like say, oh, if someone's going 3 meters per second, 3 meters per second for 3 seconds, he went a distance of 9 meters, right? This is not as simple as that because these require actually crafting the equations, right? So I'll quickly go over what each of these are again, but it won't make too much sense about how you get all these things, right? So first of all, I want to ask you guys, do you guys know what exponents are? Do you guys know what this raised to the 2 power is? Yes, yes, yes. Okay, I don't have to go over exponents. Good, good, good. Okay. If someone doesn't know, that's also okay. I can give a quick explanation to anyone who doesn't. Good. Or you can ask Ethan. Ethan, I'll also tell you, right? Just private message him. He'll also tell you. Okay, good. Good, good, good. A lot of you guys already know. Good. So now what the third equation does is basically you you can you see how this second equation deals with the final velocity? This one just saying the final velocity squared is equal to the initial velocity squared plus double the acceleration times the change in distance, right? When I say it like that, does that help kind of understand what it means to you guys? Because right now all you're seeing is letters and numbers, right? When I put it into words like that, does that kind of help? And you might still be confused about why it's like squared and why it's doubled and stuff like that. That's okay. We'll get to that a bit later. But just putting it into words is what I'm trying to do for you guys right now when you're seeing these equations, right? So since we worked with the first two, you guys kind of, yeah, so when you work with the first two, you guys kind of got how I did that. So now you can almost use this, like you can just think about it the same way, right? The final velocity, because now you're familiar with the variables, right? Before you were like, oh, what are all these variables? But now since I've explained all the variables to you, now you can kind of see sort of how it makes sense. But um, so basically, it's just saying that the final velocity squared equals the initial velocity squared plus double the acceleration times the change in distance, which is basically almost the same thing as this. It's just the change in distance is xf minus xi, right? That makes sense. If Bob ends up at 10 meters from the starting line and starts 0 meters from the starting line, the difference is 10 meters, right? So delta x of Bob is 10 meters, right? Same thing here. And what I want you guys to know that T is the missing variable here. We have XVA, VAT, XVT. A is the missing variable in the first one, X is in the second one, T is in the third one, right? All four of these equations there's four equations because there's four variables that you can solve for, right? If you don't know V, you use the last one. If you don't know T, if you don't know V, then you can solve for X or whatever using this equation. If you don't know T, you don't need to because you can use this equation then, um, and so on and so forth, right? Going on to this last equation, right? X v sub, sorry, the distance is equal to um the distance is equal to v sub I t, which we can kind of see from up here, right? Do you see that kind of same pattern where we use the initial velocity times t? We use velocity times t here to get, but we are adding 1/2 of at squared, right? 1/2 at squared is what we will create as well, right? This is here for a reason. This is through equations, right? This is not just some random thing they added, right? And it is important to know that if you guys weren't here, we did the where we used the units and we looked at how we can convert it, right? So if we have the ending units as meters equals the meters plus meters per second times second, right? You see how seconds cancel out, so how it always ends in meters? It's like that for every single value here, right? There's nowhere where this value is going to be meter per second and this will be meter, right? That just won't happen. Does this make sense to you guys? Can I move on to how we create it now? So what do you guys think's confusing about this? Because we'll craft all of these equations. So if you're kind of confused about how these equations got there, yeah, yeah, the last one's a lot is confusing, but I can give an example, but I don't know if it'll help you guys, right? Let's say Bob is let's say we need to find the distance Bob goes, right? Let's say he's running 10 meters per second for 10 seconds, right? We kind of get this, we see this pattern, right? We know he's going 100 meters, right? But we also need to know his acceleration, right? Now let's say he is accelerating at 3 meters per second squared for the 10 seconds, for the duration of the 10 seconds. These two t's will always be the same value, right? These two t's will always be the same value. So if he starts at 10 meters per second at the starting line, but you know how in a race you want to accelerate faster, let's say in those 10 seconds that race lasts, he's accelerating at a constant 3 meters per second squared, right? So that means we do the 100 we got from the beginning. Sorry. We do the 100 meters we got from the beginning plus 1/2 of the 3 meters per second square he's accelerating times the 10 seconds squared, right? 10 seconds squared. So if you do the math, you get 150 plus, so you get 250 meters, right? Because 3 times 1/2 times 100, 150, this equals 150 plus the 100 meters he's going initially, right? I know this may not still make sense to you. I don't know if this example helped at all, but I hope it did in some sense. But I think it'll make a lot more sense once we start solving. Um yeah, if you guys if you, I'm totally fine with you guys chatting, but if you guys aren't able to focus because you're chatting, then I would suggest not. But if you're able to focus while chatting, then I'm fine with it. The last one will make sense after a bit. So if you guys still don't get it, then let's go through the creating of the equations. And then if you still don't get it, then I'll try to explain it to my best later. Is that fair? Yeah, yeah, yeah. Ethan or I will give you these slides after class, or you guys have this class. You'll have the slides after class. Yeah, yeah, yeah. So what Neil said was it's just like plugging the values, right? So basically, right now you're plugging in the values, but the last one will make sense once we start kind of working with this whole thing, right? Um, I know that was a lot. I'll give you guys a 2 minute break to kind of just like take a mental second to refocus yourself. You guys can chat in the meantime, but after that, I want you guys to get crafting some equations, and it'll be great if you guys had pencil and paper with you. You can grab water, anything, bathroom break, whatever. I'll give you guys until 39. Okay, are we good to go? Are we good to go? Sorry, give me a second. Okay, let's get to it. Okay, so for all four of these equations, we will use the simple definition that velocity is equal to the change in delta change in distance over time, which is a pretty fair assumption, right? If this is kind of taken almost the average, but if a car is going, if a car went 40 meters in 10 seconds, that means the average velocity was 4 meters per second, right? That makes sense. And you guys need to understand this. So please say yes or no in the chat if you don't understand this part. Does this make sense? Yes. Yes. If a car is going 40 meters per second, or sorry, if a car goes 40 meters for 10 seconds, that means it went is it the average is 4 meters per second, right? Let's say a car starts at 10 meters and goes to 50 meters, right? The change in distance is 40, right? A 40 goes here, and if it's doing that over 10 seconds, that means it's averaging a velocity of 4 meters per second. Good? We know that? And remember, we can use the same definition of delta x as the final distance of x minus the initial distance of x, right? That also makes sense to you guys, yes? Right now, it's going to be a lot of yeses or nos, right? I want to make sure you guys understand this. Yes, it's a constant rate almost. Does the delta x also make sense to you guys where I did this? Yes? Okay. Good. Moving on to the acceleration part, we have the acceleration. This is a bit trickier, right? Sorry, I don't know why I did that. Acceleration is equal to delta or the change in velocity over time, which is another fair assumption, right? If a car goes from 30 meters per second to 40 meters per second over, let's say, uh, 5 seconds, it's the average acceleration is 2 meters per second squared, right? Because the difference of 30 and 40 is 10 meters per second. The car gets 10 meters per second faster over 5 seconds, right? So this means that it accelerated for in those 5 seconds, it accelerated 2 meters per second squared, correct? Is that also a fair assumption we can make? Yes. Makes sense. Yes, 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 yes. Good, 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 good. This is very important, right? Without knowing this, we cannot craft our equations. You didn't, which part did you not get? The acceleration one or the velocity one? The velocity one? That's a 30. Sorry, this is a 30. Um, so basically the velocity one is taking the average. Ethan, do you want to type to her in chat while I move on? And if she still doesn't get it, I can go over it again once. I'm glad that you're vocal about it so we know and you don't get confused later on. But I'll go over the velocity one once again because I don't want anyone to be confused, right? You can use a simple example again. If Bob starts at 10 meters and ends up at 20 meters, right? This is a distance of 10 meters, right? That means he's moving 10 meters and let's just say over 2 seconds, right? If he's going, if he's covering that much distance in 2 seconds, he is actively averaging a constant velocity of 5 meters per second, right? Because 5 times 2 is equal to 10, and 10 over 2 seconds, 10 meters over 2 seconds is equal to 5 meters per second, as 5 meters per second times 2 seconds is equal to 10 meters. This is interchangeable, right? I'm gonna move on now. If you have any questions, feel free to ask Ethan in chat. He puts it in words very good. So very well. Good, good, good. Let's move on to the first equation, right? This was the x equals the initial distance plus velocity times time, right? This was the first equation, right? So we're going to start crafting this by using the definition of this that we just covered, right? Since since we know that delta x is equal to x minus xi, right? The initial, the final meters minus the initial meters, right? Using both of these facts that we have, right? But using both of these facts, we can solve for the, sorry, solve for the first equation, right? So let's start by using this. I'm gonna label this um, 1 and 2. So I can just refer to this as 1 or 2, right? So using the second equation, right? V is equal to change in x over t. We can multiply each side by t to get v times t is equal to delta x, right? Change in x, right? And since we know that delta x is equal to this, right? We get that velocity times time is equal to x minus x initial, right? And if we're trying to solve for this final distance that we go, we can just add, um, let me hide my name so it doesn't keep on getting in the way. Okay, good. Um, and if we just add the initial distance to both sides, we just end up with velocity times time plus initial distance equals the final distance, right? Tell me if I went too fast there. I can cover this again. But does this kind of make sense to you guys? Feel free to, if you guys need me to repeat it again, I'm more than happy to, right? Kind of, kind of. What part do you guys like kind of not understand? Okay. So I'm gonna repeat it again, but what I'm gonna need from you guys is, sorry, is my writing unclear? Okay. I'm gonna delete this and make it more clear. Okay. So what I'm gonna need from you guys now is I'm gonna need feedback every time I make a step so I know where you guys get confused. Okay. Without that, you guys might be confused again and I won't know where to help. Okay. So please, please, please feel free to just tell me at what step and I'll label them even. I'll number them out and just tell me at what step you're kind of not understand. Right. So first, the first thing I'm gonna do, number one, right? Number one, I'm gonna take delta x is equal to the x minus xi. Okay? Does that make sense? Does the first step make sense? I'm gonna be doing this quite a lot. Yup, yup, yup. Okay. Second step. I'm gonna take, well, why am I doing that though? Because this will be used later. This will be used later to find the final distance, right? We don't need to find the we don't want to find the change in the distance. We want to find the final distance, right? We because what the change in distance is the final distance minus the initial distance. We don't need to know what the initial distance is because we're already going to be given that most likely if it's in the equation, right? The second step is velocity equals this change in x over t, right? An example you can use for this is Bob ends up at or starts at the starting line. Bob goes from 0 meters. So, oh, I'm on the eraser. Sorry. Goes from 0 meters to 10 meters. Sorry. He goes up 10 meters, right? And this change from 10 to 0 is 10 meters, right? You can kind of relate this back to the first equation. That's just the change in how much distance he covered, right? 10 minus 0 equals 10. Fair? And let's say he does this over a span of 2 seconds. Seconds, right? It's a fair assumption to make that his velocity is equal to 5 meters per second, right? Because if he's going 10 meters and if he's covering 10 meters of distance in 2 seconds, he's mostly likely covering 5 meters in the first second and the other five in the next second, right? Which we can just say is 5 meters per second, right? Does that step make sense to you guys? Yes, yes. Also, Geetika, did I answer your question about the why we were doing that? Or are you still yes? Okay. Good, good, good. That's the second step, right? The third step to know is we want to now get x by itself, right? If we want to get x by itself, what we're going to do is multiply t to both sides. If we multiply, sorry, I'm going to do this delta. I'm just going to rewrite the first equation, and now I'm going to do this. V multiplied by t equals delta x over t multiplied by t, right? I don't want you guys to get confused by this multiplication symbol, which is also why we don't do that usually. I'm going to put a dot is also a way to signify multiplication, right? So I'm going to put a dot for right now. So we can clearly cancel out both t's here, leaving v times t equals delta x, right? Correct? Yes. Do you guys get step three? A little? Does what part of step three do you feel like you're only getting a little, Tanish? If you guys are wondering why we're multiplying each side by t, is because we're multiplying each side by t because we want to get this distance alone, right? That's what this equation is trying to get us to do, right? We want to get this x alone, right? And to do that, we have to take steps in order to do that. So we're going to cancel the t on this x side to try to get this x side alone. Yes? Yeah. Okay. I know that's where you guys kind of fall apart most because you guys don't know I'm multiplying each side by whatever, right? I should have probably clarified earlier, but that is the goal of this equation, right? So now once we have this v times t equals delta x, this is where we think ahead, right? Yeah, we are creating kinematic equations. That's what we're doing. Um, this is where we thought ahead, right? This is where we first defined delta x as x minus x, the initial x, right? This is where we were like, oh, let's just define our variables. And we know that delta x is x minus x sub I, right? And we don't want x sub I in our final equation, or we do want it in our final equation, but we don't need it as what it's equal to, right? That can be on the VT side, right? So since we know delta x, man, sorry, delta x is equal to the final distance minus the initial distance. We know this, right? Because we did this back at step one. Yes? That's going to be this fifth step. I'm only doing that sorry, wait, that's only the fourth step, right? I'm not going to do anything else for this fourth step. I'm going to make this as simple as possible for everyone. Yes? Yes, yes, yes. So we can input this in, right? We won't be confused when man, sorry, this is kind of slow on my end. So minus x sub I, right? You won't be confused when I do this now, right? This makes complete sense now. Yes? Yes, 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 yes. Okay, good. I'm gonna kind of combine the next one also into step five because I don't want it to be too many steps, right? So if I'm trying to get this x alone, like how this one is, right, over here, I will add x sub I to each side, right? Vt plus the initial um, distance equals the final one. Bang. This is first equation. Okay, I don't care about. Is that an F? Yeah, that's an F. I don't think we should put an F there because it's not needed. It's just more writing. We can just say normal X. It's all the same. Just know that. And then if you ever want to solve, let's say, I don't want to make it more complicated, but if you ever want to solve for the initial distance, if the question ever gives you the final distance and you ever need to find the initial distance, you can just do this, right? You have the final distance minus VT equals the initial, or sorry, this is X initial, right? This completely makes sense, right? Since we already found out what the final one was, correct? That's a completely fair thing to do, correct? Sorry. Wait, yeah, so I just converted the equation basically. I can move it back and forth however I want because now I have this final equation to work with, right? You can play with it whatever you want. If the equation's asking for the time and it gives you the velocity and both distances, then you can try to solve for the time. It works back and forth for any one of these variables in this equation. I'm gonna give you guys 2 minutes, and I also need 2 minutes because I have to go charge this computer really quickly. So feel free to do whatever you want within these 2 minutes, but I'll be back in just a second. Okay. What if Bob can teleport? If Bob could teleport, then you wouldn't need to use any of these equations. But since we have to follow the rules of physics, teleportation cannot be real. Okay, I'll give you guys 30 more seconds. Are we good? So these equations will progressively get harder, right? The third and fourth one, it'll be great if you guys just kind of understand it, right? Because it's so hard to understand that for anyone confused on step three, yes. Yes, yes, yes. Yes, 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 yes. Ethan was our TA was confused on step three, so he needed to go through it himself. Don't you guys don't have to follow that deeply into what he said, but yeah, as long as you guys get it. Good, 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 good. I hope you guys have all these written in your notebook so I don't. Even if you guys don't, I think the annotations will show on the recording that is taking place, so do not fret. Okay, are we good to go to the second equation? So, uh, this is this is kind of confusing, almost the beginning step, but we know that we are solving for. So it's always good to know what you're solving for first, right? We are solving for the final velocity. This is what we're solving for. And what it is saying is it is equal to initial velocity plus acceleration times time, right? Makes sense, right? And I know this seems a bit confusing, so let's go over this once again. This time, since it's showing like this, our first step will be the equation we were given back over here, right? We have acceleration is equal to delta v over t, right? This is what we are given right here, and we kind of understood it, right? If someone starts at 10 meters per second and they move to 20 meters per second, that means they averaged sorry, let's do this here. 10 meters per second to 20 meters per second. That is 10 meters per second of a change, right? They went 10 meters per second faster, right? That, and let's say they did that over 2 seconds, right? That means they're going, you can kind of use the same thing I was doing earlier, right? They went 5 meters per second accelerating in the first second, and then another 5 meters per second accelerating in the next second, right? So now we can kind of say that 10 over 2 is equal to 5. So the constant accel I do not think that teleportation is possible because that has to do with destroying destroying and recreating particles, which is not part of physics. So a lot of people do think that teleporting is not possible, but do not quote me on that. Um no, I don't think it is possible. I do not think it is possible. Uh I don't know. Okay, back to the topic at hand, right? We have we have 5 meters per second squared, right? Does everyone understand the first step, what I did, right? This was back when we first defined it. I just want you guys to make sure you guys still have an understanding, right? Yes. Please be vocal because yes, step one is just the definition. Because kind of what are you kind of stuck on still, Tanish, in the first definition or first step? Let's say I'm just okay, I'll say it one more time, and then if you still have are confused, then I'll have Ethan try to explain it in words. But let's say Bob is going 10 meters per second, right? Bob is currently in a race. He's at 10 meters per second. The first person, or he's second, right? Let's say he's in second place. He needs to be in first place. In order to do that, he needs to start running at 20 meters per second over the next 2 seconds, right? That means he has to be accelerating 5 meters per second squared every single second within those 2 seconds to reach his goal of 20 meters per second, right? So that's where we kind of get this 5 meters per second squared here, right? And if we have that, the second, so I'm assuming all you guys understand that, right? I'm assuming all you guys understand that. Okay, good. So again, remember what did with delta x, where um where we did the x minus xi. It's the same exact thing over here, but with v, right? Delta v just equals the final velocity minus the sorry, I don't know why I put an x there. Minus the initial velocity, correct? That's just step two. We went through this with the distance. I just want you guys to know this is the same exact thing with velocity, correct? Just type another yes if you guys get it. You don't get it. Um, okay. So like what part do you not get? Sinchana? Am I saying it correctly? Which part of the second step do you not get? Oh, the first two steps I'm just defining, right? Though they're not related at all currently. I'm just defining what delta V is equal to. I'm not like multiplying anything or I'm just defining what delta V is equal to in this case right now. Sorry, I should have started with that. Right. Now I'm gonna, in both slides, the first two steps, we're just defining what delta X in the first equation was, right? Now I can use both of these definitions to create the equation, right? Let's start off with inputting delta. Uh, it doesn't matter. Actually, what I'm gonna do is here is I'm going to I'm gonna kind of don't read this loud, or you guys can do it either way. But what I'm gonna do right now is I'm gonna keep it as A equals delta V over T. And then again, I want to keep the velocity on its side, right? So I'm gonna multiply each side by T to get rid of this. I don't know how to multiply. I'm just gonna put this times T, right? To get rid of this T, right? So I'm gonna do AT is equal to delta V, correct? You guys understand step four or three, sorry? Does that make sense to you guys? Yes, yes, no, yes, anything. Also, we only have 20 minutes left, so if I could get it would be great if I could either get responses faster. Yeah, yeah. I'm just doing the same thing last time. It's great if I could get responses faster, or I might just go a bit faster because the last two equations need the most time, right? This is like almost identical to the previous equation but we were doing, but with just different letters, correct? So now I can expand delta V using this definition that I had here, right? So AT equals VF minus VI, final velocity minus the initial velocity, correct? I can move on to the next step. Does this make sense to you guys? Yes. How did you get change? The change was just, Ethan, do you want to answer that in chat? Good. Okay. Next step five is, so we're trying to solve for final velocity again, right? This is what I circled earlier. This is what we're trying to get. And you see this clearly here, but there's a initial velocity. So if we just add the initial velocity to each side, we just get AT plus V sub okay, I don't want you guys to get confused with the plus sign and the T. I'm trying my best to um do it, but equals VF, right? This is just the whole thing. This is it. Good? This tells us how the final velocity is related to the initial velocity plus acceleration times time, correct? Good. Am I able to move on to the... Okay, so this is where you guys are going to have to lock in. This is, I arguably think the third equation is harder to solve for than the fourth equation. That is because, do you guys know how to expand parentheses? So if I have x plus y, and then I have like A plus B. Do you guys know how to expand this out? No, 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 yes. Okay, I'll quickly go over this, right? So basically, if you have, do you guys know how to do this? Where if I have one variable and I'm doing this, do you guys know how to do this? Okay, I would appreciate if you guys typed a bit. Just do a N or a Y if you guys know or yes. Y, no, N. Yes. So basically, this uses the distributive property, and this is where we get A, and you just multiply A and X and A and Y, right? So it'd just be AX plus AY. It's pretty simple once you get the hang of it, but it's the same thing with these with this equation. It's almost the same thing, right? If I have X plus Y and A plus B, you see how you did this where you multiply. Ah, shoot, I sent it the sorry. Let's do it like this. You see how this or X distributes to both the A and the B. So you get um, XA plus XB, and then you have the Y do the same thing. You distribute this to the A and then you distribute this to the B. So you have YA plus YB. This is basically it, right? You just distribute each variable to each variable. Oh yeah, Gavin's also kind of a helper here. So if you guys if he just drops information, he'll be just helping. So don't worry about him. Good? Can I move on? We only have 15 minutes and I want to answer all your guys' questions as best as possible. Good, good, good. You guys are doing very well. I'm surprised you guys are keeping up. Good. Okay, the third equation. Ah, okay. This is where it gets tricky. We have a new definition now, okay? So basically, you know how we have the velocity. This is what I was talking about earlier, actually, right? If do you guys know how to find an average of two things? Basically, if you want to find the average between 1 and 3, you just add them up and then you divide by 2, right? And then you get the average is 2. Correct me. Yes. It's the same thing with the average of velocity, right? The average of the velocity is equal to the initial velocity plus the final velocity over 2, correct? Does that make sense to you guys? Just use variables instead of numbers here. Correct, correct. Yes, yes. Good, 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 good. This is tricky now, okay? We know from previously we solved for this, right? This we were assuming before that we were using average velocity, right? But now we're actually going to substitute it in, right? Let's go back to the this equation, right? You see how delta x is equal to vt here? This one, right? You guys get this? Yes. Yes, yes. How we got that, right? Same thing. We're going to use that in this case, right? Sorry, right? Same thing here. It's just pattern recognition, right? We have delta x is equal to vt. And back there, we assumed that v was the average, right? That I should have probably clarified, but we assumed that this was the average v, correct? So now if we use this to our knowledge, again, these two are defining the things, right? These are not related in any sense. We are just defining, correct? Yes. So I don't want you to think these are related by any means. It's just defining. Good, good, good. So now is the tricky part, right? Now it's wow. Wait, sorry. Okay, good. So I'm gonna rewrite that because it's a bit messy over there. Equals vi plus vf over 2, correct? And delta x is equal to v. average times t, correct? These are both definitions we went through. I'm going to label this one, two. Now, this third step, you see how we can input this average here, right? So if we put this average instead, we get delta x is equal to the initial velocity plus final velocity over 2 times t, correct? This is where it might get a bit tricky. So, yes, the steps one and two are definitions again. They're not going to be related, or they are related, but okay, can I slow down? Okay, good. Again, I labeled these steps, so if you guys are confused on any step, just tell me. I'm gonna label these definition steps. Def def steps. Type some Y's or N's in the chat if you guys get it. Good, good. We're good to go. Can you re-explain step three? Okay. Basically, oh, I forgot. Oh, sorry. I completely forgot to say what we're solving for. Sorry. We are solving for delta x in this case, right? Sorry, is it? Sorry, I don't think it is. Let me. Yeah, okay. We're solving for x in this case, not delta x, sorry. This is split up into two slides. This is split up into two sides. So this equation, we are solving for the final x, but with different variables than the first equation, right? The first equation used velocity, time, and initial distance. Is that it? I think, yeah. And then this one will be using acceleration, time, and velocity, correct? So yeah. So no, sorry. These slides are flipped right now. We're solving for VF squared on the last equation because that's the hardest one to solve for. I forgot that I did that because of the difficulty, but this one's slightly easier than the other one in my opinion. So I'm gonna go through, yeah, we're solving for the final x in this case. So I'm going to go through step three again. You just input, since we know that velocity of the average velocity times time is equal to delta x, instead of the average velocity, I'm going to use this equation that we got and input that for this instead. So then we get initial velocity plus final velocity over 2 times t. Is it also okay if we go a bit over class, like 10, 15 minutes over just to complete all this? Yeah, plugging step one into step, technically, yeah, plugging step one into step three, two, sorry. Yes. Okay. So the fourth step now, since we have that, this is you have another class. Um, is it okay if you looked at the recording after class? Because I want to finish all this in one class so you guys don't forget later. Okay. So the next one, right? I'm gonna erase all this. Right, erase. I don't, can I erase the, yeah, I'm gonna erase this area as well. I'm gonna keep the step area though. That's the one we need. Okay. So the fourth step here is to substitute. Oh, okay. Sorry. Remember when we got this equation, right? Yes. This is when we solve for the final velocity. Type some Y's or N's if you guys remember. Yes, yes. I should have put this in the definition steps as well. Sorry, I forgot that are I switched the slides up, but confusing the three. Okay, but sorry, this is part of the definition steps. I'm not gonna add a I'm gonna put like a question mark. Should I? Yeah, I'm just gonna put a question mark step, like because I don't know what other symbol to do. Let's do star actually. I'm gonna do a star. This is gonna be a star step. So we have VF plus VF is equal to VI plus AT. Yes, the slides are posted in the Google Classroom, so you guys can go over it once again. But we're also going to use this equation for this next part, right? Do you guys see something we can do here, right? We can see that there's a VF here and there's a VF here, right? Does that make sense, right? Yes, we can see that as the final velocity in both places. So like what we did with the step into the second step, we can kind of do that with the star step into the third step, right? We can put this final velocity, we can put this final velocity equation that we have here in place of this VF, right? And this might get a bit confused. I'm going to do it up here since I have more space, but this plus VI plus AT. And this was equal to the VF, right? If you look at the average was VI plus VF over 2. Yes, in this case, yes, we can do that because we don't but in this case we don't want to see a VF in our final equation. So when you see a V sub F like this and you're trying to solve for the distance, you can just use the initial velocity, right? Like that. But um if you're ever given the final velocity and you don't have the initial velocity, you can kind of reverse the role where you have v sub f minus at is equal to the initial velocity, and then you input that for the initial velocity. But for right now, we're not going to do that because we don't need to, right? This is not part of the four kinematic equations, right? But this is, right? Do you guys get this part where we do this? I'm going to label this step 5, right? And this is all over 2 times t, correct? Remember, we still have a over 2 and t. In that case, I just expanded it to make it easier for you guys to see, right? Correct? Okay, since we have that now, oh, is it? Oh, sorry. My handwriting is pretty bad. Sorry. Let me erase this and do this part again then. Okie dokie. Okay, so you can understand step 3 though, right? So I'm gonna just label this step 4. Sorry, so I'm going from here to here, right? I needed more space. I needed more space, so I'm not gonna keep on going down. Um, we're plugging in the VF to get VI plus VI plus a T over 2 times T, correct? I'm going to put this in parentheses just so you know you do this first. Okay, good. Does the step 4 make sense to you guys? Yes, yes, yeah. I'm moving on to step 5 now. Okay, since now we can just combine the terms that we have. We know that v the initial velocity plus the initial velocity is just equal to 2 times the initial velocity plus at t over 2 times t, correct? I just combined these two v's together for right now, correct? Yes. Okay. Moving on to step six. Now, what I'm gonna do is I'm gonna separate this so I get 2v sub I over 2 plus at over 2 times, and this is still all in parentheses, times t, just so I can cancel out these two twos over here. So then I just have, or sorry. So then I have um I just have vi sub I left plus at over 2 times t, correct? I just wanted to get rid of the 2 so I can keep it clean. And now what I can do is I can just multiply everything by t. Remember what we did in the beginning, or not in the beginning, what I taught you about the distributive property, where I can just multiply this t to here plus, oh shoot, I forgot to say this. This is still important. Okay, you guys knew that though, right? It was just from back here. I forgot to keep on adding it. The delta x is still important. We still need to keep the delta x there. Correct? Plus at over 2t, which t times t is just t squared, right? So what we can do is just we can do over, I don't like how that arrow is so close. At squared over 2 equals delta x, correct? Yes. Tell me if you guys are getting lost because I'm seeing less yeses than before, which is concerning. Yes, everyone's still following along. Correct. Yes, yes. Good, good, good. Okay, now I'm seeing more yeses again. All right. So then for step nine, we know, remember for delta x is equal to x minus xi. I think we've got that pretty good in our heads, right? You can't see that xi, sorry. Where we got this in our head pretty solidly, correct? And to solve for that final, we just add, oh my God, sorry, this is really slow. Plus at squared over 2 plus x sub I equals the final x because this is equal to x minus xi. So when you just add xi to each side, you get, oh, this is so crammed. Sorry. No, okay, there we go. I'm gonna do this. At squared, and then I'm gonna have the 2 there, right? This is the final step, and then we have it solved. Any questions here? Good. Okay. So technically class did end, but I want to go over the fourth equation. I want to go over the fourth equation. How does it get harder? This is already too hard. Do you get it though? Do you get it? Does this make sense though, Sinchana? Yes, but it's still hard. Yeah. It gets harder. And a lot of the times when I'm doing physics problems, I don't know the answers to them, but it this is still considered relatively hard, but it does get harder, especially when you start using calculus and everything else to solve. But that's not a concern for us right now. Okay, bye, Tanish. No, we're not going to be learning calculus, Gavin. Wish we did though. Okay. Next, I can delete all this. Does everyone have this down? Can I delete all these annotations? I don't want to delete it. I don't want to delete all my hard work for no reason. So just if I have five or more people just saying yes in chat, I'm gonna delete it. But if I have someone saying no, I'll keep it on. Oh, that's 5. Thank you. Okay. I'm gonna clear. Okay. Oh, that's painful. Oh, okay. Fourth one. After this, I think I'll end class, even though I did have a book get set up, but I think we're already taking a lot of time. Okay. Let me just quickly make sure that I want to make sure I have all the definition steps down before I. Okay, so there's two definition steps here, okay? There's two definition steps here. Def steps, correct? We have VF equals V sub I plus AT. Remember we solved for this? We solved for this back 45, 50 minutes ago, okay? So hopefully it's still in your brain, but yeah. And then type yes if you remember this. Yes. Yes, yes. Okay, good, good, good. The other equation we had was delta x is equal to vi plus vf over 2 times t. Correct? You remember this still too, right? This is just the average velocities times the time. Remember we used that back here, right? Right here we use that. Sorry, not right there. Here. Yeah, yeah. Sorry, not this one. This top one, correct? Yes, we have that down. Good, 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 good. That's good foundation. These are our two steps we have, right? These are the two things we're going to be working with this time. Good. So right now what we're solving for is the final velocity squared. Final velocity squared, right? And basically, we because we're solving for the final velocity squared, we don't need to use t in this case. We just need to have final velocity, initial velocity, and x, correct? And acceleration, sorry, right? We don't need t, so then we're gonna try to take out t. So we're gonna have our first step be what? Yeah, VF minus VI over A equals T, correct? Because you minus over here, you minus VI, and then this just equals AT, and then to get T alone, you just divide each side by A, correct? Cross out. This makes sense, correct? Yes. And so now, since we have this, we can, oh, you want me to label that step 3? Okay, sorry. I'll label it step 3, and then I'll label the first two 1 and 2, correct? And so now we're gonna input this equation in 3 from 3 into equation in 2, right? So we're gonna take this t and we're gonna take this and put it here, correct? Does that make sense? We've been doing this quite a lot. So once we have that, we get vi plus vf over 2 times VF minus VI over A equals delta X. Correct? This makes sense? Step four makes sense? I just plugged it in. I just plugged T in. Okay. Step five now is we're gonna use something. It's called difference of squares, but I don't want that name to scare you guys. The difference of squares is basically what we were doing earlier, right? So if we're multiplying these two things, right? Correct. Because you see how we're multiplying these two things up here. Do you see those four things we're multiplying? Yeah. Because the bottom just becomes 2a, right? You just multiply 2 into a, you get 2a. But the top is what's hard to multiply, correct? So what we're gonna do is we're gonna take this I, we're gonna multiply to both sides. We get vi times vf minus vi squared, correct? Because vi times negative vi is just negative vi squared. Yes, it's factorization. I just want to make sure everyone has it down because I know some people um don't know as well. So then we do the same thing here. We multiply VF by both sides. So we get plus VF squared minus VFBI, right? So we can clearly take these two out because they're the same thing. And then we're left with VF squared minus VI squared. This is basically what the difference of squares is. It's when you're one parentheses is adding two values and the other is minusing those same two values. You can just take this squared minus this squared, right? Correct? So, um, if anyone's confused, just please feel free to say in chat because I know it's pretty hard. Yeah, like Gavin said, it's pretty useful to know all this. So then you have VF squared minus VI squared over 2a is equal to delta x. We don't want to forget the delta x we were dealing with, right? Here was the equation we inputted it in, and here's the delta x is reoccurring, correct? And again, we are trying to solve for the vf squared. So basically, I'm gonna put step six here, okay? Don't get confused. Just it's almost over, yeah. Like 2 more minutes and then you'll get all the equations you need to know how to create. I'm gonna go over this as best as possible, as fast. I did not understand what you did in steps three and four. Oh, steps three. So basically I just inputted so basically in step one, I kind of solved for t. Using step one, I solved for t, and then I inputted that solution for t in step three to step two. I think Ethan could type in chat what I kind of did because I'm gonna keep on going with this, but give me 2 more minutes and then I'll be done. Okay. So then we're trying to get VF squared by itself, right? So we're just gonna multiply each side by 2a to get VF squared minus VI squared equals 2a delta x, correct? And then you minus VI squared, or add VI squared to each side to get VI squared plus 2ax is equal to VF squared, correct? Are we good with that? Okay, if everyone who gets it is knows how to do it, you guys can leave the class, but I'm gonna go over it with the people who need me to slow down just a bit. So you're uh feel free to leave if you guys get it, but if you don't, I'm gonna explain it once more. So basically, Whoever's confused, do you guys get the definition steps I used? The V sub F is equal to V sub I plus AT, and delta X is equal to the average velocity times T, which is just V sub I plus V sub F over 2 times T. Do you guys get that? I need you guys to say yes or no because I need to know where you guys are getting confused. Geetika, Sinchana, do you guys where did the delta go in sixth step? Oh, basically, you see how in the fifth step it was VF squared, or it was just okay, Geetika, let me answer her question real quick and then I'll come back to you. Okay. Basically, you know how VF squared minus VI squared over 2A is equal to delta X? I just kept it as delta X and I just multiplied 2A to each side. This is where the delta X is right here. Oh, did I? Oh, oops. I forgot to put, sorry, that's my bad. Here. Is this why you're confused? Because I didn't have a delta X there and I just had an X?
Yeah.
Oh, okay, okay, okay. Sorry. That was my mistake. Does that make more sense then, Sinchana?
Yeah, so that's just the last step, right?
Yeah, yeah, that was last step. That's how you just get VF squared equals VI squared plus 2AX. Yes, delta X.
Yeah, okay.
Okay. Um, okay, Geetika, next to you. In step four, I didn't understand how you got 2 and A. So basically in step four, I just multiplied. So